So today I'm going to be presenting empowered JORC compliance through LIMS using a C-class and a bit of introduction about myself. My name is Dion Borg. I'm the General Manager for LIMS here at Datamine based in the Brisbane office. I have a chemistry background and used to work in a nickel refinery up in North Queensland for about 10 years. 6 years of that time I was using C-class. So I started out, uh, managing as a consultant for C-class, installing, going to customer sites, installing and training and supporting our customers. And a lot of our consultants have a chemistry degree like me, so it's very important to understand how laboratories operate. If we are to configure the software to suit their needs. And, we've personally experienced a lot of the problems and issues that you guys have in your laboratories. So a picture of me with some of the Datamine team and the SGS team in their Madrid laboratory. Um, so for those of you that aren't familiar with Datamine, this image shows the current software solutions that we own and support here. Globally, we have something for every part of the mining cycle, from exploration, production, reconciliation, engineering, environmental, and lab logistics, which is obviously what I'll be presenting today. So today we'll be going to be focusing on the C-class, which is part of the laboratories portfolio. So a question I'd like to pose to everybody on this call, are you under pressure to deliver resource and reserve statements? I think, investors and regulators, expect reliable technical reporting that they can trust. And, JORC reporting demands confidence in every input, grade, recovery, cost, and schedule. So now your teams rely on lab results to inform critical assumptions. But, is this data audit ready? Now, I guess here's some risks that you probably can't afford. Lab data that arrives late or is inconsistently structured. QA, QC issues that actually go unnoticed until after reporting. And then limited traceability creates uncertainty for the competent person and other stakeholders. So I guess one bad assumption can equal a flawed reserve, a financial risk, or worse, a damaged reputation. So I've got a couple of example of what's happened when lab data does go wrong. So Red Pine exploration in Ontario in 2024, the company found that they had 532 analysis out of 98,000 in its databases that had been manipulated. So those numbers flowed into internal models and a filed NI 43101 technical report, which was resource effective from May 31st, 2019. And the company actually alleges the former CEO interfered with the results and transmitted by the lab, so prompting corrective work and re-verification, which obviously damaged their reputation. Second one is Thor Mining or Thor Energy in Western Australia in 2022. A dramatic lab mix-up, a 4 meter interval initially reported as 12.2 grams per ton of gold was later corrected down to less than 0.01 grams per ton of gold. So a big difference. And why? Well, the lab discovered a sample swapped with an internal standard, right? A big mix up in the lab there. So issued a ASX correction. This is a classic example of erroneous lab data inflating results and potentially misleading the market until it's corrected. Third one is Sol Gold in Ecuador in 2016. An independent laboratory issued a reporting error on a high-grade intersection at Casacabel. The company published a correction, ironically upgrading the interval and the share price moved on the news, illustrating how sensitive, markets are to single assay intervals and results. And the fourth and last one is Eclipse Metals rather in Greenland in 2023. The company retracted an ASX release after realizing the lab methods weren't actually appropriate, and it awaited reanalysis before redisclosing. So it also shows method selection or laboratory workflows issue can also force public corrections, which can lead to misleading investors. So I guess our advice here to remove your lab bottleneck is to look at a laboratory information management system, or LIMS, and this brings structure, speed, and control to your laboratory. It ensures every assay is logged, validated, and traceable from registration through to reporting. And QA/QC workflows are built in with automatic flagging, approvals, and audit trails. So, really, we want to, shift your thinking in rather than your lab being a bottleneck, make it a strategic asset. So, with QA-driven and data-confident reporting, really does start with your labs. So having a standardized life cycle from sample registration all the way through to reporting, consistent every time. Having automated QA/QC flags, so you got your duplicates, your blanks, your standards, your replicates, all defined, and if they're out of range, they're flagged in CCLAS, and the associated samples will not be reported. Audit-ready traceability, so all data from the scheme or method is timestamped and indicated by who changed that result. And then fourthly, the feeds into modifying factors. So validated grades, recoveries, and contaminants inform reserve calculations. Okay, so I'm just going to move on to the demo now. So I have a CCLAS open already, and what I'm going to demonstrate to you today is the import of results off a AAS instrument, so atomic absorption spectrometer, and it's some gold results. So obviously, as part of CCLAS, we create a sample information file where you upload the results to the instrument. There's no typing of sample names onto the instrument because obviously that creates errors. So once the sample information file is uploaded to the instrument analyzes the samples, then creates a data file. And I'm going to show you what an example of the data file looks like. So it's just a text file. Sorry, bring that up again. It's just a text file that contains all the data, and then CCLAS will be able to uniquely identify those records. So CCLAS has an application called Task Scheduler. It runs on a PC in the laboratory, and it's a schedule that runs automatically. I'm showing you this manually. Obviously, users don't have to do this. So automatically, as soon as that instrument has finished those results, it will save a file to a network folder, and CCLAS will pick that up automatically. I'm showing you this manually. And once it's picked up, and then it moves to an application called Online. So you can see the samples coming in here on the left-hand side being imported in the CCLAS, the results on the right-hand side. So we're importing a bunch of unknowns, blanks, and QCs. And then we're going to go into CCLAS and show you those results. So I've got an application called Data Entry, and I'm going to open up that lab batch that we just imported to show you some results. So as I mentioned, they are fire assay results. We're just focusing on the gold here that was imported. So obviously we've got, you can put a proper QC regime. So the first one here is a blank. So obviously a blank is used to detect contamination and carryover. So that's really important if you were analyzing and you don't want to have that contaminating your next run of samples. So that's why a blank is important. Then you can see a preparation duplicate. I'll talk about those different colors in a minute. So the preparation duplicate is used to check the precision and representativity of your sample preparation. So sample preparation is very important in your sample analysis to get reproducibility. And then you'll see a replicate. So the replicate is used to monitor analytical precision and repeatability of the analytical technique. And then you have a standard, which is run to check to make sure, your preparation and the instrument is calibrated correctly. So you can see a bunch of colors on here, and I've purposely made some of these files to demonstrate a few things for you. So if we have a look at the preparation duplicate here, so you can see this sample that ends in 1439, we created a preparation duplicate for. So that was prepared twice, and you can see that it's out because it's the sample is outside of the range. It's flagged it red, right? So it won't allow me to validate those results as is. So as a demonstration, I'll just fill in some of these, some of these blank cells. And if I try and validate this job, it will say, I'm sorry, you can't validate this job because there's a failure. Okay. So, and I'm just going to get rid of these NAs just for the, oops. Just bear with me. Unlock, I hit the wrong one. Now, one. So you can see that this value is marked in yellow. So again, it's a replicate. It is not outside of the range, but it's warning that it's close to being out of range. So it's just a warning. And obviously, going back to this 4.61 that failed, obviously, if you would need to go and reanalyze this sample again. Say I went back and reanalyzed that sample and it came down to 0.45. It's then within that range and it's not flagging it as red. So now if we have a look at down the standard, if you highlight over, it's actually expecting the standard value to be 4.1. So it's 3.99, which is below the minimum value of 4. So again, you'd probably if your standard is wrong, you would probably reanalyze all of those samples again because it demonstrates that there's the calibration of your instrument that's probably not correct. So you'd probably reanalyze all those samples again and say you reanalyzed it and it came within value, then there's no red there. And at that point, after you blank out all of the other cells, so just bear with me, let me save that because I didn't save it in between all of those changes. I'll just open that back up again. And CCLAS will now validate all those samples, and upon validation, and you can then report your results. Okay. So some other things that we use for quality control, apart from blanks and standards and replicates and duplicates, we have an application in CCLAS called SPC. It stands for Statistical Process Control. So some of our laboratories run SPC on a big widescreen monitor in their data entry screen of the laboratory. So it's in a public space. So when standards, you can track standards, blanks, replicates, all of those things. when they come up on the screen, if they're out of range, it's in a public space, so it makes the chemist responsible for their quality control. So if they see a standard out of range, they've got to go and fix it because it's showing that their analysis wasn't correct, right? So very good tool for quality control, and laboratories used quite heavily for our customers. We also have the ability to, for laboratories, each month they've got to report quality control samples. So we do have an application that allows them to, um, uh, look at the performance now, and that's automatic, so it runs reports and statistics for the chemist to check. So it saves them time in running those manually as well. On top of that, I think one of the other things is audit trails. So just showing you that lab batch that I just opened or worked on. And this is a demo one, so I've been doing a lot of different data on it, but just to give you a demonstration, it shows you here that I was logged in as the CCLAS MGR. That's the staff. That's just the management user. That was the time, the application, and there was a sample was overwritten. And if you remember, I changed it from 3.99 to 4.1. Okay, and it showed it was a standard, what the ident was, and what the keyword, which is a unique identifier. So very easy to audit any jobs in CCLAS. Everything is fully auditable. Okay, so that's the end of the demo. I'm going to flick back now to the presentation. So I guess without lab confidence, everything else is actually at risk. Errors in assay data compromise your reserve statements, reworking delays, project approvals, and technical sign-off. A competent person may withdraw or include caveats, and investor confidence is eroded if disclosures are revised or retracted. So, CCLAS does enable, JORC compliance. Your stakeholders trust your data and the decision it informs. Your reserve and resource models are built on validated, auditable inputs. The lab is no longer a risk, it's a competitive advantage, and you meet your reporting deadlines with confidence and no caveats.